This is Thomas. He works at a repair shop for the SBB where they repair trains. Because trains are made out of many different pieces, they need to have a lot of spare parts in their inventory in different quantities and with different prices. Each repair requires different items. This makes it very difficult to predict what items they'll need, when and in what quantity. How can Thomas figure out which parts are most important? Thomas has chosen to use the ABC analysis. This analysis helps to identify spare parts which will have a significant impact on the overall inventory cost of the SBB's repair shop. Also, it can be used for identifying different categories of spare parts that will require different management and control. It is based on the Pareto's principle that states that with 20% of the effort, you can generate 80% of the value. Similarly, the ABC analysis's main idea is that inventories of an organization are not of equal value. Thus, the inventory is grouped into three categories: A, B, and C, in order of their estimated importance. Looking at the SBB's item list with the reference numbers, Thomas will first calculate the annual consumption value by multiplying the price per basic unit of measurement and the consumption of such unit. He now has the absolute annual consumption value for each item. Dividing the annual consumption value with the sum will give him the percentage value for each spare part. He then sorts all items according to the percentage value from high to low to see which products are the most costly. He then calculates the cumulative value, and finally, by simple if formula, he can classify all of the items into A, B, or C accordingly to see how the spare parts list cost is distributed. He now has a lovely graph showing the ABC curve. A trend can be identified when graphing the accumulated values. Very few spare parts account for a majority of the cost, while many spare parts barely influence the total cost by more than 1 or 2%. The ABC analysis shows Thomas, with the help of the cost curve, that spare parts can be grouped into the following three categories. The A items represent around 20% of the items, which account for 70% of the annual consumption value of all the items. Thomas has to pay close attention to these products. A small number of products account for a major part. He can't afford to make many mistakes here, as minor discrepancies or mistakes in inventory management can increase inventory cost and tie up capital or cause a stock out. An example for Thomas's A parts are brake calipers, as they are fairly expensive and are prone to wear and tear and need frequent replacement. B items, roughly 30% of the inventory items, account for 25% of the annual consumption value of the items. The C items, around 50%, accounts for 5% of the annual consumption value of the items. These spare parts are usually inexpensive and not regularly used. Applying ABC analysis to the SBB spare parts inventory allows Thomas to see which spare parts are most important to manage, as they are either used a lot or are very expensive. But that's not all. The uncertainty of the items needed are also central for a repair shop like the one where Thomas works. Does Thomas really need to have a locomotive front window on stock if, based on past data, he only uses it every 2 years? Probably not. Therefore, Thomas uses an XYZ analysis in addition to the ABC analysis with the same articles in order to classify items according to the volatility of their demand. X items have very little variation in demand. They are characterized by steady turnover over time. For example, every second train might need a light bulb replaced. The Y items have some variation. Although the demand for Y items is not steady, variability in demand can be predicted to a certain extent. Some factors can be known or predicted, like seasonality, implying that you will repair more air conditionings in the summer and more heaters in the winter. The Z items have the most variation. Demand for Z items can fluctuate strongly or occur sporadically and are very difficult to predict, like a train's front window. For XYZ analysis to work, it's vital to understand and apply an appropriate time span for assessing demand volatility. Then, in order to conduct an XYZ analysis, Thomas first needs to look at the standard deviation of each of his articles and the mean average from the data he collected over the past. In a second step, he must divide the standard deviation by the average to receive the coefficient of variation for each item. He can then set the class limits and categorize the items accordingly, and for this, he uses a simple if function. He now knows the annual consumption value through the ABC analysis and the frequency of consumption through the XYZ analysis. But why all this effort? This will now help him plan ahead. Combining these two will help him to figure out the item's predictability. Items categorized in the top left can be ordered automatically due to regular consumption and high predictability. This is often used in just-in-time inventory management, when the automated shipment from a production buffer implies the items arrive exactly when needed. This increases efficiency, cut costs such as inventory holding costs, and avoids dead stock. On the right side, we have items that are kept in the warehouse, ready for Thomas to use when repairing a train. This could be things like screws, bolts, and washers. In the bottom row, we see items that are brought sporadically, whenever they are needed for repairs. These are mainly items that are seldomly needed, like a train's front window or a train's rear view mirror. For the B and Y articles in the middle, they can be allotted in any of these three groupings, whichever Thomas thinks fits best.